Hello everyone and welcome to our lesson. Our key focus today will be on data representation, and for data representation we'll be looking at number systems. Now there are three key number systems we'll be focusing on today. One of them is Denary, the other one is binary, and the third one will be hexadecimal. Now Denary number systems are number systems that are to base 10. Now all this simply means is that we have 10 different combinations of numbers that we can possibly use to make up these Denary numbers. And these numbers are 0 to 9. You can rightly say that Denary numbers are our everyday numbers, the numbers you would use when solving maths problem, or where you're doing normal calculations using your calculator. You are almost definitely using Denary numbers. So a typical example of a Denary number is 2732. I have written the number here in its purest form, and you can see I've used a subscript there 10, and that denotes that the number is to base 10. When you solve problems in maths, for example, you would write numbers as 2732 without really putting down its subscript. Now, one thing you may have noted from working with Denary numbers is that each digit is 10 times more than the one to the right of it. So in our example here, you can see that we have 2 lots of 1000. We have 7 lots of 100, we have 3 lots of 10s, and then we have 2 lots of 1. So if we break down the combination of this number, we have 2 times 1000, 7 times 100, 3 times 10, 2 times 1, and this gives us a total. If we add all of them together, we get a total of 2732. The next number system we're going to look at are binary numbers. These are numbers that are to base 2. And what this means is the fact that they are made up of a maximum combination of these two numbers, 0 or 1. Now binary is commonly referred to as the language of a computer system. Now this is because computer processors have circuits in them that are made up of billions of transistors. Now the digits 1 and 0 represents the on and off states of a typical transistor. Each digit in a binary number is always 2 times more than the one to the right of it. And here is an example of a binary number. I've written the subscript there 2 to denote it in its purest form. Okay, so when it's written like this, we know we're definitely working with a binary number. Some questions where you might see 1101 written without the subscript. In that question, they may have told you that you are working with a binary number. So you need not worry to denote if this is to base 10 or to base 2. Hexadecimal number system is a number system that represent values to base 16. Now what this simply means is that hexadecimal numbers can only be formed with the use of 16 possible values, 0 to 9, A to F. Now if we break that down further, you can see all the possible combinations, all the possible values that can combine to form a typical hexadecimal number, 0 to 9 and then A to F. When matched against a Denary number, you can see here that 0 in hexadecimal is still 0. in Denary, and that goes up to 9. You can see 9 in hexadecimal is 9 in Denary. But A in hexadecimal is what we represent as 10 in Denary. B in hexadecimal is what we refer to as 11, and it goes up to F, which is represented using 15. So what are the common uses of hexadecimal? Now, hexadecimal is used to shorten the length of binary, of a typical binary number. You can see here EA is an example, and that subscript there, 16, just denotes that it's an hexadecimal number. 2B9 there is hexadecimal to base 16, and this is not 473. This is actually 473 to base 16. Now, each value here represents 4 bits, a nibble. Okay, so E there represents 4 bits. A there represents another 4 binary bits. So you can see there we have shortened 8 binary bits there. 1 byte gives us 2 hexadecimal values. Other uses of hexadecimal, it's used in defining memory location. It's also used to represent IP addresses in the case of IPv6 and MAC addresses as well. And it's also hexadecimal is also used for displaying error messages in reference addresses. In the next part, we will be looking at how to convert binary numbers to Denary and Denary back to binary. We'll also look at how to convert Denary to hexadecimal, hexadecimal to Denary, and to binary. Thank you.